This is your introduction video to our next virtual lab. There is a lab sheet for you that kind of gives you our goals, how we set up the simulation, how you're going to run the simulation. You have two different options here. The reason why you have two options is the simulation itself is a Java-based simulation. I could not find one that was not that I liked. So if you have the capabilities of running Java and want to run it this way, you can click on this link and go in and run the simulation from there. If you don't have the capabilities, you're using just an iPad. Okay, iPads can't run this. You can just come down here and click on my YouTube video instead. This video is a video of me running the simulation on my laptop. So you can watch that anywhere on any device to make this happen, okay? So either option is available to you, okay? Before you get that, you should be watching this video, and this is what you're actually watching right now, so you've clicked on this already to get inside that, okay? In our simulation, we're going to make one pretty major assumption. That assumption is that the reactants or products are gases trapped in a sealed container. The simulation is going to give you information by molecule, and we know that to find concentrations, to find equilibriums, we need concentrations. So by taking this simulation and assuming they are gases in a container, we then can directly relate molecules to concentration, which we've done in some of our other practice problems before also. You have your data to analyze here. So I would work through this. It's kind of like your working document. And then as before, we will be diving into questions inside of Schoology to actually solve this, okay? So we need to get into the simulation. So if you click on this link right here, it's going to bring you to the simulation. It's going to download it and open it up. It'll look something like this. If you're just watching the video, it's just going to be me showing up on the screen on YouTube. Once the simulation starts, we're going to set this to 100. So we're going to start with 100 molecules over here in our reactant side and none on the product side to run the reaction. Okay. Now, the simulation, if I turn everything down and let it just run very fast, no activation energy, equal sides here, very quickly we go from reactants slamming over to products and then back to reactants, and they change color based off of what side they're on automatically as you see them cross back and forth. So we see a very quick dynamic equilibrium happening here. Okay, I like this simulation because it doesn't make it perfect 50-50 all the time. It's constantly dancing between high 40s and low 50s as the simulation truly is running. So it's a really good simulation to show that dynamic equilibriums are messy, that they're not always perfect 50-50, but if you average this out, you would get that equilibrium. Now, this is not a realistic equilibrium because in real chemistry, we don't have scenarios with no activation energy. We have activation energy that has to be dealt with, okay? Because not every particle is allowed to cross from one side to the other. And in most chemistry, one thing takes less activation energy than the other. So this one might only take that much activation energy, okay? So let's say we reset it, and we reset it like this. So we have a difference in our energies here. And then we run it, and we can time it actually. Reset this, so we want 100. There we go. Now we got it going. Now in this case, we see that the reaction does run, but they don't jump over quite as fast, okay? And this equilibrium takes a little more time to establish itself as it goes back and forth between the two things. The simulation also shows us kind of a visual. We have way more A, our reactant side, than we do B, our product side here. And it gives us some color coordinating too to see that difference between those two things, okay? So we're going to need to let the reaction run a little bit of time, and we're going to collect data about every minute, okay? Now, the simulation itself runs much faster. If I start this, if you look, it's running much faster than real time. So when I say you're collecting data every minute, you're really collecting data about every 30 seconds or so. Not even that, less than that, about every 20 seconds or so you're collecting data, okay? So we're going to collect the equivalent of 30 minutes of data in about 8 or 9 minutes is what we're going to do as we run this, okay? Now, the simulation itself, if we start this thing from scratch and I start it over again, and again, if you mess with the parameters and need to start it over, please do so, because what that does is it allows you to start it the same way that everybody else is. So now we have a clean slate here, and I'm just going to go 100, and I'm going to touch nothing else over here. that's a simulation that we're going to be dealing with as we, little email popped on my screen there. It's a simulation that we're going to be dealing with as our setup, okay? So don't change your heights, don't change this, just type in 100 and you can start your timer and it'll run, okay? So you know the time it's happening and then you know the simulation is now running. And this is the data we're going to collect is based off of this information right here, okay? And that's how I set up my video also. So you have this information and it's going to run the equivalent of 1800 seconds on the video. So you would do the same if you're running the simulation at home, okay? Now, this data has to be collected someplace. So we're going to switch over to the iPad and I'm going to show you how we're going to collect the data and analyze the data, okay? So moving over to the iPad, what we see here is we're going to go into that Veneer software that I asked you to download at the beginning of trimester 3. So we're going to go into Veneer Graphical Analysis. And I'm choosing this because I think it has a really simple interface in terms of collecting data and graphing that data for us, okay? We're not going to collect it using any sensors. We're going to use that bottom option there called manual entry, okay? So where it says 1, 2, 3 right here, we're going to click on manual entry at the bottom there. And it's going to spin, and it's going to open up a graph for us. Now, we're going to set a few things up to get us rolling to make our lives easier later on. The first thing we're going to set up is our X and Y categories over here. Our X, if we click on the 3 little dots here, our X is going to be our time. So if you click on the 3 dots and go to options, so click on 3 dots, column options, that's your first one. This is our time. So we're going to call this time, and that's going to be in seconds, okay? And we can leave everything else the way we see it and hit apply, so that's our time. Now the Y column, if I click my 3 dots, I'm going to go to column options. This is going to be my products, okay? And we really don't have a unit for that, so it's really a concentration. So maybe we'll use, you know, a capital M for molarity if we want to as we do this, or we could use a C or just whatever you feel like for your units there. I'm going to use an M for molarity here in our products. Again, we'll leave everything else the way we see it, and that is going to be our products. Now, we also need to see our reactants here, okay? So to do that, I could enter in data for reactants and products every time, but that's twice the work. So instead, I'm going to do a little trick with my data here. Under the products column now, under those 3 dots, there's a calculated column. So it's the 3rd option down. It says add calculated column. So I'm going to click on that, and I'm going to have the software solve for the reactants for me. Okay. Again, this is going to be a molarity again, so I'm going to do a capital M for molarity. And this time, I don't really want decimals. We have whole numbers here because each an individual molecule representing that molarity. So I'm going to call that 0, and I'm going to insert an expression. So under where it says expressions right here, I'm going to insert an expression. And what I wanted to do is do a subtraction between my products and my reactants. So to do that, I'm going to go down to the 3rd one down where it says A times X plus B. So the A times X plus B, this guy right here, and I'm going to click on that, and now it gives me this option. Under parameter A right here, I'm going to change that to a -1. So I'm going to take my products, take it times a -1, that way I get a subtraction, and then my parameter B is going to be 100 because I had a total number of 100 molarity or 100 molecules here. So now I can take 100 minus my products, and that will give me my reactant. So I hit apply, and over here, if we scroll back and forth, we now see our time is our X, our products is our 1 column, and then our reactants is the other. The beauty of this is you will not need to put anything into that column, and I'll show you that right now. So let's say at time 0, we have 0 products, right? As soon as I hit return, it automatically inputs 100 for me in my reactants. So I have that data already done, okay? On the graph, it shows me at time 0, I have 100% or all of that or 100 molarity as reactants. Now I'm not seeing the products on this graph. So if I click over here where it says reactants, so if I click on that, I can turn on my products also, okay? I can turn them both off, what I want to do. So right now, clicking on this allows me to change what I'm looking at. Okay, so now I see my reactants are 100 and my products are 0 molarity to start this thing off. All right. So now I'm all set up. And as I collect data, all I have to do is fill in the time and the products, and the reactants will fill for me, and the graph will graph. So let's say, for example, after our first time commit, and I want you guys to collect data about every 60 seconds. So basically every minute, according to the simulation, you're going to collect data. So it doesn't have to be perfectly at a minute, but let's say after 60 seconds, there was 13 products. And then after 120 seconds, there was 20 products. And then after 180 seconds, there was 24 products. I don't know how fast that would be. If we do that, you'll notice that as we go down, here's time 0, here's after 60 seconds, here's after 120 seconds, here's after 180 seconds. It's graphing as I work, okay? And that's what I really like about it. Now, once I have all my data in, okay, and I'm ready to analyze it, I'm going to show you what that will look like. So I'm going to go to an experiment I did before, and I'm not going to save this guy. Oh, look, equilibrium experiment data. So here is data. I ran this one other time before. This is not the exact same parameters that you will have. Notice how I also only collected every 100 seconds. You'll be doing every 60 seconds. But here's what I got, okay? So let's take a look at my data. And if we take a look of the data, we start off again at, 100% reactants, 0 products, and they ran as such, okay? So when you're done, you should see something looks similar to this. They may or may not cross each other like you see happening right here. When you guys do your simulation, this depends on how we have that set up. You are going to need to get one piece of data from that. And one thing you're going to need is once these cross and they now are running parallel with each other, okay? So probably about this portion of the graph here, I would say, where here, they're still sloping. Once they get about here and they're running nice and parallel, we're going to highlight that data, and then over here where you see the graph, this little button over here, we're going to click on that, and it gives me some options. And I'm going to use View Stats. And inside of here, for the blue data, I can find my mean value, which is right here, 39.6. And I can also find my mean value for the red data, which is 60.4. Those two numbers are going to become important as you do your analyzing and looking for your KEQ value, okay? So again, if you need to rewind the video and rewatch how you did that, that's how you get that data. You just click and select, go down here, View Stats, and you can find your means and stuff. And we've done this before in class also, okay? Please take a screenshot of this when you have it all done. So, it should look something like this. You can move this around, get it out of the way. You won't need to have both of them on there, just so I can see that you have the data there, and we will use that in part of our lab as we move forward, okay? So that's your setup, and you can see it both graphically and numerically what is happening in your iPad setup here, okay? Once you have all your data and you're able to analyze it, we'll go back to the sheet. You will start doing the analysis part of this, and then you'll turn it in. Guys, that is it. If you have questions on lab, please let me know. We're going to have plenty of time to do this lab and work your way through it. It's kind of the last practice before we do our assessment on this module. Thank you.